In this video, I'll show you how to do the structural modeling of any circuit which is given in a vhdl. So for that, first you have to know the entity declaration, and I have posted a video on an entity declaration and I'll provide the links in the description. So let's start with the structural modeling of this circuit. And remember one thing guys, the structural modeling deals only with the interconnection. It does not deal with the logic which is behind the circuit, only the interconnection, how gates are connected to each other, that's all. So let's start with the entity declaration first and then we'll do the structural modeling. This is the circuit and the circuit name is CKT, and A, B, C, D are the input ports, J is the output, this and this are the OR gates, and this is an AND gate, and E and F are intermediate signals. And in case of entity declaration, you don't have to mention the intermediate signals, only the input and the output of the circuit. So let's start with the entity declaration. Entity CKT is port A, B, C and D are input port with standard logic as the data type, and G is output port with the standard logic as the data type, and CKT. This was all about the entity declaration. Now let's come to the structural model. For the structural modeling, follow the syntax which I am using here. And for the structural modeling, the first thing what you have to do is the declaration of the components, and then you have to declare the signals, and then the interconnection which are made using the creation of instances. So the first thing is components. The components are the gates which are used in the circuit, and in the structural modeling you have to deal with the types of components, not the number of components, the types of components. So in this circuit we have got three components, two of them are the OR gate and one is AND gate. So basically there are two types of component, AND and a OR gate. So during the declaration of components we'll declare here only the two components. So let's begin the structural modeling. So the first keyword what you have to write here is architecture. This will be followed with the architecture name. You can give here any name. For simplicity, I am naming it as structure of. This will be followed with the entity name, that is CKT S. The first thing what you have to do is the component declaration. So let's write here component OR. Remember one thing, while declaration of the components, this is the component name, and this should not clash with the name or keyword which is previously in the vhdl. So if you write here OR, this will clash. So take any other name, take gate 1, gate 2, or OR 1 or 2, take OR A or B, any of the name. One thing, it should not clash with the predefined keywords in the vhdl. So I'm taking as OR 1, component OR 1. And this is an AND gate, so I'll take component AND 1. While declaration of components, you have to follow this syntax, port. Now you have to declare the input and the output ports, just like we did in the entity declaration. Remember one thing in the component declaration, that if you are using A, B, C, D and G in the entity, so you cannot use these letters again in the component declaration. You have to take any other substitute. Let's take STU in this case, and for the AND gate we will take X, Y and Z. Since you have to declare only the types of components, so no need to declare this OR gate twice. It will work with the same declaration. And yes, if there was a 3 input OR gate, you will have to declare it one more time. Since there are only the same components here, OR gate with the 2 input, you will declare this only one time. So let's take another letters like ST for input and U for the output. So S and T will be input, and let's take standard logic as their data type and U as output with standard logic as data type, and component. Here you have to take care, while end of the entity we were using the end circuit, which was the entity name, but while ending the component you have to use the keyword component, end component. Okay, you don't have to write here end or one, you have to write end component. So the next thing is declaration of the AND gate. So let's take component and one port. We'll take here X, Y and Z for E, F and G, and X and Y will be the input ports and G will be the output. So X and Y as input with standard logic data type, and Z as output with the standard logic data type, end component. This was the complete description of the component declaration in the vhdl. Since there were two types of component, we are declaring here two components. After the declaration of the components, what you have to do is the declaration of the intermediate signals. In this circuit you can see the A, B, C, D and G are the ports and E and F are the intermediate signals. So the next thing is what you have to do is the declaration of these signals. How you will declare the signals is with the keyword signal. Write here name E and F colon with the data type, that is standard logic. This is the declaration of the signal. And now we have completed the declaration part, that is the component declaration and the signal declaration. Now we'll proceed with the architecture. There is a keyword begin which is used to start the instant declaration. So in this circuit we have got 3 gates, so we'll declare 3 instances, 2 for the OR gates and 1 for the AND gate. Let's begin with the instance declaration. So begin, since there are 3 gates, so we'll take 3 instances. Let the name be x1, x2 and x3. Again guys, this is all up to you. You can take any instances, instance 1, 2, 3 or any keyword. For simplicity I am taking here as x1, x2 and x3. So the x1 is the first gate what we have to declare or what we have to create the instances, this, and the second is this, and the third will be this. So x1 for this, x2 for this and x3 for this. So x1 will be OR1, since this was a OR gate and we have created the component OR1, and this will be followed by the keyword port map. Port map means mapping of the component ports and the entity ports. So in this you can see A, B and E are mapped with the S, T and U. So right here, sorry, A, B and E. This was the syntax for the declaration of the first instance. The second instance is also of the OR gate. So right here OR1, again port map, and in the entity it was named as C, D and F. So right here C, D and F, same as the entity, and we are using here the intermediate signals also. And the third instance was for the AND gate, and the ports were E, F and G. So AND 1 port map, this is E, F and G. This is all about the instance creation. The number of components will decide the number of instances which need to be created. Now the instance declaration is over, so end architecture, that is structure. This was the complete description of the structural modeling in case of vhdl. The first you have to declare the entity, and this you don't have to mention the intermediate signals, and then you have to declare the structural modeling architecture. In this, first determine the types of components which are present. In case of architecture, you should know the types of components which are present. Then types of components will decide the number of component declaration, what you have to declare in this. Declare the 2 components, then declare the intermediate signals which are present, and then create the number of instances equal to the number of components which are present in the circuit. This was all about the structural modeling in case of vhdl. I hope this video was helpful, and for more videos stay tuned. Thank you for watching.